Alright, so let's get on to part 2 of building the Cosmic Web. The second setup we're going to do is a little bit different, so stick with me. It's a little bit harder to put together, but we'll get there. So diving into Simulation 2, I already have a little bit of a setup going where I've created a box. And this box is 1 by 1 by 1 and a uniform scale of 1. And I've added a for loop, and all this is a for each primitive loop. So that's all you kind of need. And I'll show you in a second how you can generate the metadata here. So I've added a for each prim loop. And all I've done is added it into here, connected my box to my transform, and my other copy node, which you'll see down here, and then gone here and created output meta node. And that's how I've gotten it. So down here, these are the changes. So the max iterations is 4, and what this is for is just setting up kind of like a fractal shape, because I wanted a little bit more of an interesting shape for this design, as well as some more randomness. So I created more of a fractal type of thing. For the transform here, this is a little bit more complicated. So if I open up the editor here, so it's Alt-E, you can see the little equation that I've done and I put in here. So all this is doing is grabbing data from the metadata node, and then also adding the iterations to it and going over to it by a different multiplication of power. So that's what you have. One thing I will say during the setup, when you experiment with the setup, do not change this over from polygon to polygon mesh, because you will have the worst crashing time of your life. So keep this as it is, please. Down here inside the for each loop, you have a copy stop. I haven't really done any changes to this, but you can see it there. And then these are all merged together here to create this little shape. And then I've added an offset, and what that is just added some density to our fractal kind of shape. The next thing I've done is added a volume VOP, and all this has done is created some randomized density from the shape. And you can see the frequency, the offset, and the roughness, and the max octaves here. These are all promoted to the surface. But if we dive inside, we can see that I've gone from the P scale here to the attribute noise, added a trigonometry function, and then outputted it to the volume VOP. So on the attribute noise, these are all promoted to the surface, except for amplitude, which I wanted to stay in there, and these are the changes. Over here, I'm just going to go additional web coloring. And the reason this setup is going to be a little bit different, this is just for a more lazy way of doing things. There are 2 ways to build this setup, so I thought I'd show you guys anyway. And then I've added some coloring. So this is bright blue color. And then I've added an out null. And what this has done is just created some background noise to our little setup. And that's pretty much the starting shape of it. So if we added a null for our controller, because we want to control these values, right? So we're going to go controller web once again, and color that a different color so we can grab it. Parameter interface folder, and starting picture. There you go. Unfortunately, I turned that off. So what I've done is this. The only thing I really want to change and make sure it's up here is probably the ISO offsets and the uniform sampling division. So we'll put that in there. Remember to change that, kids. And then we'll sampling divisions volume. There you go. And then we go to our outer shape. And because this is going into additional colors, okay, so yes, we want to include this one in the starting geometry, so we're going to put the frequency in there as well. We'll put the roughness in there. And we're going to put the max octaves. The only thing we're not going to put in there is the coloring for our additional web. So what we're going to do is put another folder down, and that one's going to say additional web coloring. And we're going to have the color in there. There you go. And we can have the option to show a color wheel if you want, and I'll show you what that looks like on the controller. So if we go over here, it should look like that now. You can see a color wheel. So I'll accept that, and then the next step I'll show you in 1 second after we lay down a null. Put that as out. Starting geo. And we'll color that yellow, just so we know where we are. Alright, so the next step of this is creating some other background noise to match our out volume. And so what these background noisy lines are going to do is just add more volume to our set simulation. So I've added another null, colored it yellow, and put out volume. I've scattered some points. So there's a force total count of 6, 7, 8 on here. And then relaxed iterations is on. I've added an attribute randomize, which is taking the attribute name p scale. Global scale is 0.17. And then we have the option in creating a custom ramp for these points. Interesting. Alright, so this custom ramp should be working for the p scale now. Not sure why it decided to pause on me like that, but hey, I guess things happen. Then I've added another attribute randomize, which is handling the rotation, which is on the n, which is rotating them based on the normal, so n. There's 3 dimensions, and the distribution is inside a sphere. So we go to copy to points. This is what everything should look like. The box is a polygon. Its uniform scale is a 1, size is a 1, 1, 1, so nothing's changed there. That's how it should look like. We can change the distribution pattern of the clumping like that. So it's a little bit less clumpy. The next thing we can do is go down to our scatter and scatter some more points on them, so the force total count is about 2,341. Then we've connected adjacent pieces. So these are being connected by adjacent points, and the search radius is a 0.1. Max search radius is 100. Resample these. So the length is 0.06. So if you can see here, points, less points. And that's how you know the resample is doing its job. Fuse together any points that are overlapping, and then lay down a wire stop so we can generate some polygon radiuses. So the wire radius on this is 0.008. Turn off this so you can kind of see the mesh better. And then we've subdivided this mesh so there's more axes to our polygons. And because this is a pretty heavy background kind of noise, I've added a file cache, and I've just cached everything out. So what we can do is just cache this out again. There we go. I think this background noise might be a little bit too heavy. So what I'm going to do is probably turn down the P scale just a little bit. Just a little bit. So we get some better points there. Yeah, that works. Yeah, that was way too heavy. So we'll save the disk again. There we go. And we'll go to the first frame just so nothing goes wrong. We'll also save so nothing goes wrong. We'll go to VDB from polygons, and this is where it will get a little bit heavy, so you might have to wait for Houdini for a while. Alright, so now that our VDBs are ready, we can reshape them. So we've expanded them into these orbs. with our dilate, and the offset is 6.03. And then we've reshaped them into this globular kind of shape. And then we can convert them back to polygons, and that's what we've gotten. And we can poly reduce them a little bit more. And you can see here we've percent to keep, and that's pretty much it. Then we can divide them so we can get these circle-esque shapes. So over here is what our attributes kind of look like. And then we can add a start group, which is a base group that is choosing a point that should be on our figure here. So we should see it somewhere over here. It should be like bright yellow. Ah, there we go. There he is. And then our end group is all the other points on our model. So now we want to find shortest path, and this is what it's doing and what it's generating, which is pretty cool, and this is on the outside surface. We can then resample this, so we can have a maximum edge length of that and make it kind of wild. And then we can set a rest length. Okay, so the next thing we added was a rest stop, so this is just setting a rest position. And then I've added an attribute wrangle, and what this attribute wrangle is doing is just saying the position is in relation to the rest position. So then we resample this, and it suddenly becomes a lot smoother. Actually, I'm not sure if I need this anymore. I don't think I need that. Sorry about that. Some extra node troubles. And then what we can do next is just sim everything out. So we'll save this to disk. And now what we can do now is tell it the width of the wire radius of our lines that we want. And then we can go to convert. So we'll convert those all to polygons. The interesting thing about the wire stop is that it doesn't always convert everything to polygons, so you do have to be aware of that. And then we can generate a VDB from these polygons. And we'll let that cook out. Hello everybody, and sorry if this looks a little bit different, but I was in the midst of editing this tutorial and I found out this section of the tutorial just completely shut down while my computer was recording, so I have to refilm it, and if anything looks a little bit different, this is why. So we're gonna get started where we left off, which was from VDB from polygons. And don't mind how this value is turning green. I'll walk you through everything at the end. But anyway, we went from converts. If we jump back up here, from these nice little lines to VDB from polygons. And this voxel size is currently sitting at a 0.01. And the distance VDB is on surface. The VDB, reshape VDB I've added next, its offset is 0.6 and is on dilate. I've then converted this VDB to a polygon, and we've got some really nice tree-like structures going on. And then we got VDB from polygon, and currently you can't really see anything, so I'm going to turn this to a dark, and you can kind of see it through here, which is really great. I've then decided to color this, and you can see this color here, and then we have our null at the bottom, which says out fractal lines. So now we're going to walk through, and I'm going to go to my controller web and walk you through how I added all these values. I'm going to open up my controller. I'm going to go to edit parameter interface, and I'm going to close up everything that I've done. Sorry, things happen when you don't expect them. So this is where I've created a folder that says background fractal lines. So we're going to jump up to the top of this simulation. Just ignore everything on the side here. We're going to go through that later. And jump up here to our out volume. So how I've created this folder is simply by dragging a folder into here, dragging it down, and naming it. That's all you really need to know. And you can delete the parameter like that. So I've called this one out fractal lines. So I'm going to go to my controller, and I'm going to background fractal lines. So if we look at here, our scatter should match the value we see under original fractal lines. So what you can do by what you can do is once again just drag this parameter into here. Of course it won't let me because it's already in there, but you can drag these parameters into here and just rename them. So I've done that with this value. I've named this value on our null original point amount. So these are the original points that are generating our fractal lines. The next value that I've entered, I've gone down to the attribute randomize, and I've left this alone. I think it's okay. The rotation is alright. The next thing, I've left this box alone. And then I've gone down to this scatter here, and I've dragged this value over here, and I've called this shape point amount, and it should match up onto my null like that. So this is the original shape point amount, and this is the value. I've then added a separator, and I've dragged that down from down here just to separate it on my controller. I've gone down to connect adjacent pieces, and I've left that alone. Resample, once again left that alone. Fuse the points, left that alone. Wire, I then changed this to, this should be shape radius. Yes, so this is a shape radius. This value is dragged up to here and named shape radius. Subdivide is left alone. And then we have our save to disk, and I've just dragged that over here and then added that in our tree. Down here we have our VDB from polygons. That one is our voxel size, which I renamed voxel size shape. And then this is the dilate amount. So originally this comes in as something different, but I've just renamed it as that. The reshape is our road amount. So that should be the same as that. Added another separator. Convert is left completely alone. We have our polyreduce, which I've just named as polyreduce amount, onto here and dragged over here. And then I've created two little subfolders called line generation and final volume. So the line generation, inside of it is our groups down here, and I'll get to that in a second. But for divide, we've kind of left that alone. We don't really need anything from it. From our start group, we'll let Houdini think that out. Okay, don't mind me here. I just canceled cooking because I'm lazy. I've created a start group. So in the start group, I've dragged the base group into here and labeled it as point start group. And then have our end group, which is left alone in this case. Below it, we have our find shortest path, which is completely left alone. Our resample, once again, left alone. And our rest position, left alone, as well as our additional resample. I've then added this save to disk file cache into here, and then our wire radius is placed here, which is our line radius, which is great. So I'll just close this one up. And then the final volume folder underneath here, we've left our convert alone, so this isn't added inside here. Our VBD from polygons is our voxel size sampling, right, which is right here. Our VDB reshape SDF has been changed to a dilate amount on our final volume folder. Convert VDB has been left alone. VBD from polygons has been placed underneath this separator to this and its name has been changed to final voxel size. And then the final thing in here, we've added the color. So we've dragged this over here and it's under here. And you have the option of showing a color wheel. I've turned that on in this case. So that's pretty much it. And now we'll move on to the next step. All right, so the next step of this is just go back to our starting geo null with this volume and generate some interesting points and lines. So the next step was to create two different pathways with our shortest path function and create two different point groups. Both of these have two different types of points. This one has a start group of 9,000 points. And then we've converted this from VBD from particles to the size. So you can see the voxel size is this, point radius size is this, etc. We've then smoothed these VDVs, they're more clumped together, and then reshaped the SDF so it's a little bit more scattered. We've added some more points on top of them, so there's 1,678 points in there, and then we have group 1, so these are all placed in a point group. Going over to this pathway, we have our points over here, so there's 23 points in there. We've added an attribute randomize, so there is a p-scale of a range of a minimum value of 0 and a max value of 1. Copied to points, these little spheres. So the sphere over here is a polygon, its uniform scale is a 0.08. And then we've added a scatter, which is this. Then we've added our little point group, so all these are placed in a group, and these two scatters should have the same amount of points in them. Just be prepared for that. So these are now merged together, so you can see them looking like that. It's very trippy. Then we've added a point wrinkle, and what this point wrinkle is doing is sort of generating kind of like our connect adjacent points kind of null and node, but in this case is doing it with vex. So if we open up our editor, we can go here, and I'll show you the code that we've done. And there you go. So then we've connected this to our find shortest path. So this was on this side, this is on the other side, and the combined geometry looks like something like this. So some mesh of little points. If we were to take this out, we wouldn't find anything. But this is what it looks like. There's a max search radius on here of 100. So if we turn this down, the less points you'll get. Start group is 1, end group is 2, and the output looks like this from each start to each corresponding end. And then we've cached this out, and then we've added a null, and that's pretty much it for the line. Alright, so the next step in playing with these lines is to merge them and mesh them all together. So what we've done down here is added a fuse SOP, so just in case there are any spare points overlapping, they're all fused together now. I've resampled these, and one way to resample your lines is to just go up here, see, make sure that's working by seeing very few points here, and then moving on to your resample. I'm gonna make that like a 2. I don't think that's a little bit overkill right now, but we'll see. Then we go on to our smooth. This should smooth out our lines. And then convert it to a polygon and get it ready for our polywire down here. This is one of the heaviest steps, hence why I have a file cache right here. So the polywire settings are these. It's something really tiny. It's 0.0025. I've then cached it out. This will take about 10 minutes to cache out, so just be aware of that. And then if we scroll down here, we've got the clumping and the meshing that we have so voluntarily wanted to build. So if we go over here to our VBD from Polygon 6, we can see that it's forming these little very finely meshed things. Go to the reshape, it's pushing this outwards, BDV smoothing, reshaping, and then converting. You can see it here. And I'm going to turn off my points. I think it might be a little bit of overkill. So I'm going to go to my reshape, go like that. Maybe smooth it out just a little bit more. Okay, no, apparently not. It was more than enough overkill. Okay, it looks like it's gotta be a 1 then. By playing with the smooth, you can smooth things out more or less. In this case, smoothing, in this case, does more. Does more and make these lines a little bit smoother. So I wouldn't go to more than 2. And then over here, we have some other finely meshed polygons, or VBDs from polygons. We're once again reshaping the SDF, building it back up again, smoothing it into these clumps, converting those clumps to polygons, and then putting them in a group so we can visualize them, called star clumps. So these are going to be part of the clumps on the mesh. And then over here, we've got another VBD from polygons, much more fine. Reshaping, smoothing these, going to adding a VBD segment connectivity, and what this is doing is just grouping all the points that are not attached to each other. The red is attached, the other colors are not. And then you can add a delete to delete all the ones that are not attached to each other. So you've got this clump. Then I'm reshaping the SDF into these smaller clumps and then converting those to a polygon. And then putting this in a group called clumping. And that's pretty much all it is. And all of these are being merged together over here on this node. So they become this one big mesh. I am then converting all of these to polygons. And then I'm caching this out. And then I've added a null down here that says out mesh, and that's pretty much it. So let's cache this out and we'll move on to the next step.